the beginning, there was computation. Simple, binary. A universe of ones and zeros marching in orderly rows, like soldiers across a silicon battlefield. But you stand now at the edge of something different. Something that defies the very rules reality taught us to obey. Imagine a computer that doesn't think in straight lines, but in clouds of possibility. A machine that exists in multiple states at once, like Schrödinger's mythical cat, neither dead nor alive until you dare to look. This is quantum computing, and Google has built a doorway into this impossible realm. Welcome to the age of quantum supremacy. Close your eyes for a moment. Think about the device in your pocket, your smartphone, with its billions of transistors, smaller than viruses, switching on and off trillions of times per second. It seems miraculous, doesn't it? But we've reached a wall. Picture yourself standing before an infinite library. Every book contains the answer to a different problem. Protein folding that could cure cancer, materials that could reverse climate change, encryption codes that would take the age of the universe to crack. Your classical computer? It would need billions of years to read even a fraction of these books. This is the tyranny of classical computation. One path, one answer, one universe at a time. In 2012, a team of dreamers and physicists at Google asked a dangerous question. What if we could harness the strange twilight laws of quantum mechanics, those bizarre rules that govern the subatomic world, to compute not in our universe alone, but in many universes simultaneously? To understand what they built, you must journey with us into the quantum realm, a place where your intuition becomes your enemy. Imagine you're standing in a fork in a road. In the classical world, you must choose, left or right. But in the quantum world, you can walk both paths at once. This is superposition, the ability of quantum particles to exist in multiple states simultaneously, like a coin spinning in the air, both heads and tails until it lands. Now imagine two coins spinning together, but connected by an invisible thread that transcends space itself. Touch one, and the other responds instantly, even if it's on the other side of the galaxy. Einstein called this spooky action at a distance. We call it entanglement, the strange correlation that binds quantum particles together in ways that mock our understanding of separation. Google's quantum computer named Sycamore harnesses these ghostly properties using something called qubits. Picture each qubit as a microscopic tightrope walker, balanced between 0 and 1, between existence and non-existence. But these are no ordinary performers. They're superconducting circuits, cooled to temperatures colder than the void of space, just a whisper above absolute zero, 15 millikelvins, where atomic motion nearly ceases and quantum effects reign supreme. In this frozen cathedral of computation, 53 qubits dance together in choreographed entanglement, exploring thousands of solutions simultaneously, like a master chess player who can see every possible game at once. October 23rd, 2019. A date that echoes through the halls of computer science like a thunderclap. The task seemed simple on paper. Generate random numbers according to a complex pattern. But this particular problem was chosen specifically because it would drown classical computers in an ocean of calculations. Google's quantum processor completed it in 200 seconds. The world's most powerful supercomputer? 10,000 years. This was the moment we call quantum supremacy. Not domination, but a crossing over. Like the Wright brothers lifting off the ground at Kitty Hawk, or the first human footprint on lunar dust. A proof that we could build machines that operate by rules our ancestors never imagined. But you must understand, this isn't magic. It's excruciatingly fragile magic. Those qubits dancing in their quantum ballet, they're being constantly bombarded by reality itself. Stray photons, cosmic rays, the faintest vibration. Any of these can cause what we call decoherence, where the quantum state collapses like a house of cards, and your parallel computations crash back into a single ordinary universe. Google scientists had to build elaborate error correction systems, quantum shields against the noise of existence itself. They're running a race against time, performing calculations before reality notices, and quantum advantage evaporates like morning mist. So, where does this quantum road lead us? Imagine designing new medicines by simulating every molecular interaction in a human cell simultaneously. Picture batteries that could power cities, discovered by quantum computers modeling every possible atomic configuration. Envision artificial intelligence that doesn't just recognize patterns, but understands the quantum nature of consciousness itself. If consciousness is quantum at all. Google's quantum AI team isn't just building faster calculators. They're constructing a new language for reality. Their Circ framework allows researchers worldwide to write quantum algorithms, to compose symphonies in this strange new medium of superposition and entanglement. But they're also building towards something more profound: quantum machine learning, where artificial neural networks operate in superposition, learning from multiple realities at once, converging on truths that single universe thinking could never grasp. We stand now at a threshold, you and I, peering into a computational universe where the very foundations of reality become tools of discovery. But here's the question that should keep you awake tonight. If quantum computers can exist in multiple states simultaneously, exploring countless parallel solutions, are they computing in our universe alone? Or are we glimpsing something deeper? A multiverse of calculation, where every possible answer exists, waiting for us to observe it into being. The quantum realm keeps its secrets well, and Google's machines, they're only just beginning to ask the right questions. The future is not calculated, it is computed in superposition.